Okay, so in this video we're going to look at tone control. In particular, we're going to look at our active filters. So in terms of our active filters, we then need to be aware of our cuts and our boosts. So if we're looking at the circuits here, then this one we have a standard gain until we get to the low frequencies, and then the gain drops off. So this is going to be a cut, and as it's in the low frequencies we're cutting off, it's a bass cut. Whereas this one has a standard gain, common gain going all the way up until you get to the high frequencies, and then it reduces. So this is going to be our treble cut. Okay, so that's those two circuits there. Now these two are slightly different, whereas the gain increases on both of these. So this gain increases at low frequency gain. So this is going to be our bass boost, and this is going to be our treble boost. Okay, because the gain increases at high frequency, the gain increases at low frequency. So these are all sketch graphs, assuming you're on log, so I can do the 2-line approximation. So at the point where it changes is our break frequency on all of them, and on all of them we calculate the standard gain of the circuit using RF over Rin. Okay, now a lot of our work that we're going to be doing is around the break frequency. So let's just have a little reminder about the break frequency. So that's our formula for our break frequency. FB is equal to 1 over 2 pi RC. Now we're going to use the I don't know why, associated with C. So when we look at the circuits, we're going to use the resistor that is associated with the capacitor, and obviously that will become a whole lot more clearer as we see some circuits. So if we look at focusing in on a treble cut circuit to start with, let's just get it all into view. So there's my treble cut circuit. To make that into treble cut circuit, these are the easiest. Then treble T means on top, so I'm going to put my capacitor there on top like so, and I'm going to make it 210 picofarads. Okay, so if I then looking at calculating the gain for this circuit, so I've got a 50k over a 10k, so that's a gain of -5. all right, so that's a gain of -5 for that one. And then looking at the break frequency, well, it's the 50k resistor that's associated with that capacitor. So when I pop in my values into my formula, 1 over 2 pi times by my 50k resistor times by my 210 times 10 to the -12 picofarads capacitor. So 210 picofarads, 210 times 10 to the -12 gives me a treble cut at 15.16 kilohertz. Okay, so what does that then look like on a graph? So if I've got a graph here like so, then I'm going to have, and I've got some scaling, remember log, or it's always ones. So here I've already gone, so I'm going to gain a 5, so 2, 3, 4, 5, so there's my 5 to start with, and 15, so 1, 10, 11, 12, 13, 14, 15, so there's my 15, just there. I'm going to put a point, let's just check that I've done that right. 11, 12, 13, sorry, 11, 12, 13, 10, 11, 12, 13, 2, 3, 4, 5. Yep. Okay. So that's I would use a ruler. So ordinarily, so therefore I've got a point there, and then I need to draw a 45-degree line coming down. So I'm going to draw a 45-degree line coming down. Sorry about that. Let me just pause the video. I just realised I've just drawn some nonsense. So I just realised I've just drawn some nonsense because I think I went to the 50 point, didn't I? So there's 10, so that must be 20 kilohertz. So therefore, roughly somewhere there is going to be my 15 kilohertz. So I can draw my line across there like so, and then I'm going to draw a 45-degree line coming down like so. And obviously I'd use a ruler for that. Okay, so that's my treble cut. So let's look at our base cut, and in this case on our base cut I want the base cut to be 200 hertz, so we're going to find out the capacitor. But let's just draw the circuit. So base B equals before, so therefore I'm going to put my capacitor in there like so. So I'm going to find that capacitor that we've got in our circuit. So looking at the circuit like this, therefore I want to find the capacitor. So I've got, just slotting in the values that I've got 200 is equal to 1 over 2 pi. The resistor that's associated with the capacitor is that 2k, so times by the 2000 ohm resistor times by C. Okay, so we want to make C the subject to the formula. So therefore C is going to be 1 over 2 pi times by 2000 times by my 200 hertz. Gives me a capacitance value of 397.8 nanofarads. Okay, so there's both of my cuts. The boosts are obviously slightly more interesting in what you've got to do. So let's have a reminder here. For boosts, we've got to remind ourselves about what happens with capacitors as you go up in frequency. So the reactance of a capacitor goes down as you go up in frequency. So it has a smaller, we'll call it resistance. So let's look at an active treble boost to start with. So if we've got a circuit that looks like this, where do we put the capacitor? And in order to boost the circuit, in other words, we're changing the gain, we can either affect this value of resistance, or we can affect this value of resistance. So we want to make the gain bigger at high frequency. So if we were to put it then just here, at high frequency, the reactance of the capacitor is smaller, so it effectively makes Rin a lot smaller at high frequency. Makes Rin a lot smaller at high frequency, that then increases the gain. So the gain for this circuit, as it was done before, so we've got a gain, it was the same as the previous circuit, so we've got a gain, well, I will just work it out again. So gain on the circuit, so we've got minus RF over Rin, which equals 10 over 2, which is a gain of minus 5. There's our break frequency formula. So if we pop in our values, what value are we using to find, oh, I haven't told you what the value of C is, have I? So we've got 26 nanofarads. So let's slot in the values that we've got. So 2 pi times by what R we're using. It's the value of R associated. That's right. It's the our 2k times by our 26 times 10 to the minus 9. That gives us a break frequency this time of 3060 hertz. So let's draw that on a graph. So we've got a gain of 5, so 2, 3, 4, 5. So there's 5 on my graph, and 3 kilohertz. So 1, 2, 3. Okay, so we've got a a point just there. So this is treble boost, so we're going to have all the way up to that point, and then our line is going to go up. So I need to draw a 45-degree line in. So I'm just going to draw approximate. So 20, 30 hertz, and then 20, 30, 40, 50. So I can draw a line in like so, like so. All I did to draw those was go up by a factor of 10 on both of those to draw my line. Okay. And then finally the bass boost. So we want to increase the gain at low frequency. I suppose the clue is in the missing bit on the circuit. If I put my capacitor in there like so, at low frequencies the reaction of capacitance is very big, so therefore RF is very big. So in this case we'll do it where we've got to find C again. So if we want to find C, so FB is equal to 1 over 2 pi RC. So we're slotting in all of our values again. So we've got 300 is equal to 1 over 2 pi times by the resistor associated with is our 10k resistor times by the value of C. Okay, so then we can then do all of our rearrangements. So C is equal to 1 over 2 pi times by our 10k times by our 300 hertz. So that gives us 53 nanofarads. I know I didn't do a sketch for the previous one, but let's just do a sketch of this one, so what it looks like. So we're going to have a graph that looks like that. So there's my gain of 5, and at this point here, which we said was 300 hertz, therefore it goes up like that. Okay, and that is your active tone control.